All right, everybody. So here we go. She's all put together. So now we're going to do the final step here, which is going to be assembly and doing the calibration of this. The Rev Fs are easier to calibrate than some of the other ones because they have an integrated circuit that helps stabilize one section, so we don't have to worry about all the calibration steps, but we'll get there. First things first though, before I put this together, I'm going to build the active link. The active link is necessary to make a talk to a brother or sister compressor. So I'm going to jump to time lapse. I'm going to build the active link. Then I'm going to clean off my work area a little bit because the thing's kind of big. And then we'll start the assembly. But all that's going to stay in time lapse. And then I'll duck back out for the calibration bit. All right, so the next step and the most important step is calibration. So to calibrate this sucker, there's a calibration instruction part on Hairball's website, which is what I'm going to be doing. I'm just going to walk through it with you. I'm going to keep the video live while we're doing it, just to kind of talk you through it. All right, so with the Rev F, you only have to do 2 parts of the 4-part calibration. The last part of the calibration is optional. It's to basically to adjust total harmonic distortion. It's not really a huge deal. I don't have anything in here right now to measure THD plus N. So short of me going out and getting something to allow me to do that, I'm just going to skip it. I might have, 0.05% more harmonic distortion in my circuit than normal, but I'm not running the entire mix through stuff like this. I'm typically running like stereo stems or individual sounds, but even still, my mixes are super clean, just from an editing standpoint and all that other stuff. So again, noise is about stacking most of the time. So if I was hitting everything with this over and over and stacking up, maybe that would become an issue, but I don't think so, the way I'm going to be using it. So anyway, so we're going to be doing part 1 and part 3 of the adjustment of the calibration here. So the first one is Q bias. All right, so a couple things. One, your DAW needs to have a 1 kilohertz, 1K sine wave ready to go and queued up. And you're going to be adjusting the output of your DAW to match 0 dBu at the input of the unit. In order to do that, basically the louder something comes out of your DAW, the more voltage it's outputting. So what we're going to do, I already have a session set up in Pro Tools with a 1 kilohertz test tone. I got like 4 minutes of it. I'm just going to loop it. I have it adjusted. I have the gain staged at a point where it's reading pretty close to that, but I'm still going to start fresh. I haven't used it since I built the last one, so we'll see what happens. So this is my output from Pro Tools. Dropping into here. I'm not turning on my speakers for this because I don't think you guys want to hear a 1 kilohertz beeping or giant tone the whole time we work. All right. First things first, it didn't explode. No smoke, no fire, as they say. Off switch works. All that other good stuff. I hear the circuit clicking and moving. All right, cool. All right, so Q bias. First thing we need to do, and I can't really show you guys on the video, so we need to turn our input to mid rotation at 24. So I'm going to take the middle of the rotation. So in my case, it's actually a little bit higher than 24. If I look at where the posts line up, it's really more like 24 and a half. Or excuse me, like 24 in between on the next one. Got this in. Let me go ahead and start the test tone. All right. Theoretically, I am sending 1K out to this line. All right. So mid rotation 24, attack full counterclockwise. Let's switch to the off position. Release full clockwise, or fastest release. Compression ratio 20:1. Meter gain reduction. So another thing too is if you don't do this step, it's not gonna work. You have to set this in order to do anything. The next calibration we're going to be doing is going to be calibrating our meter so that it functions properly and actually shows us what the gain reduction we're actually getting is. All right. And Q bias adjustment, full clockwise, highest output. So this is the Q bias right here on the board next to where the power jumps in. Boink. All the way to super juice mode. Well, through this build, I learned that my fluky multimeter is kind of fluked out on me. So, see the ground lighting up. So that being said, that sucks. But, you know, so this little X-Tech guy. So I'm setting it to AC voltage. This is my backup multimeter. And how lucky am I that I thought I wasted money and I had 2 multimeters. I'm like, I don't know if I'm really gonna need this. All right, so we're gonna measure across the input. We wanna see 0.775 or really damn close. So I'm gonna sneak in with my probes here. Remember those posts I told you about putting in? Boom. I'm at 0.737 AC. That's pretty close. Oops, I just knocked the camera. That's pretty close. So I brought up the gain out of Pro Tools by 1/10 of a dB. Let's do this again. 0.742. We're getting warmer. I'm gonna do 2/10. Let's check it out now. And again, I hope to God this meter is. I bought the fluky because it was good company. 757. I think I come up a little harder. To be honest, this X-Tech is like my cheap Amazon multimeter. I brought up another 2/10. Let's see how close to 775 we get. 0.777. That's a sign to me. It says stop screwing with it. All right, boom. So now what we're gonna do is we're gonna move our multimeter to measure the AC between the out one. I didn't install posts on this one. I kind of feel like I should, but it has these holes and my multimeter will just like sit in the holes because these are like needles. So I kind of actually prefer to not have the post on this side. 4 or 5-ish volts bouncing between the two. This is adjust the output control to read 2.75. So I'm going to adjust the output control to see 2.75. So it's literally like turn it down. I come down here. Whoop. 3.02, 2.745. I mean, we're talking tiny moves on this thing. So I'm getting as close as I can. All right, and now what we're gonna do is we're gonna slowly turn the Q bias counterclockwise until a drop of 1 dB occurs. So we're gonna, until we see 2.44 across this output circuit. So we're gonna turn this counterclockwise till we see 2.44. I'm seeing a whole bunch of nothing right now. Oh, there we go. Ooh. So I got ooh, damn it, that was right there. I had 2, ooh, that is so, I mean, I'm talking like I'm putting the weight of the screwdriver against it. That's 2.44 dead on. Yeah. All right, cool. So that's my adjustment. So like the first quarter turn of that Q bias did absolutely nothing, and then all of a sudden, wham, mega voltage drop. All right, so that's the Q bias. Reduction meter tracking adjustment. All right, so back to the thing. We're gonna bring our inputs and outputs back to that mid rotation again. We're still applying that test tone just to have it, and we're gonna check across, see how close we get. We were at 0.777 before, 0.776, even better. All right, so we got that across our thing. Attack is gonna be full clockwise, release full clockwise. Compression ratio, again, 20:1, and meter in gain reduction mode. Let's just double check our schmurgen here, 776. Add a 1 in front of that, and it's happy birthday, America. All right, so we're gonna apply that. We've got our 0 dBu signal hitting. We're gonna move our meter to the output. Oops. Gonna move our meter to the output again. Probe our output. Oof. Yeah, that resistor gets hot, the one above the lamp. I just like, I don't want to say burned myself, but woke myself up. All right, meters there. We want to see 0.775 at the output. So we're gonna come back and we're gonna we're gonna crank it up just a little bit. Or sorry. There we go. Set for 0.775, not 7.75. .85, 0.761. I'm measuring the output, remember, not the input, not where my signal's coming from. This is after we've run through the circuit. 0.77, ah man, I was so close. I mean, I'm just tapping it with my finger. 0.777, which I think that's dead on even to what we're coming in here. So regardless if it's saying 0.775, whatever my out is, I want it to be the same, just so that my circuit is basically, it's not adding any kind of gain or any kind of boost in the situation. All right, bam, so that's in place. All right, so it's a set attack to full counterclockwise position off. And set input control for plus 10 dBu or 2.44 volts AC at your output XLR. So now we're jacking the input up to pass through the circuit and see it get jacked up over here. So we're adding 10 dB. So we're going from 0.775 to 2.44 excuse me, yeah, 2.44 volts AC. So input knob, bringing it up, watching our meter, 1 volt, 1.2, 2 point. Had to give it a minute and let it settle. 2.31, 2.32. Ooh, 2.449, that's the high side. 445, 444, 442. Now I'm just getting nerdy with it. Ooh, I messed it up. Tried to get cute. 37, there we go. 437 is within 3/1000 of a volt, or 3 millivolts of our target. That's close enough. So now we turn the attack control on fully clockwise and readjust the output control for 0 dBu if necessary. So we see it's 1 volt, so we need to come back down to 0.77. 775 again. Super freaking sensitive. Ooh, 761, 765, 766. Oh man, I don't want to touch it. Damn it. 773. I'll take it. Okay. Now let's set the meter to display this 10 dBu drop. When the attack is control on. When the attack is off, and you see plus 10 dB at the output. I get back at 2.44 volts AC. Okay, I'm gonna have to go back to the top on this one. I'm gonna bring this back up to 2.44. So I'm actually having to turn the input quite a bit again, which means we've got some adjustment to do. 2.437, that's cool. All right, 2.436. So set the meter displays 10. When the attack is off, fully counterclockwise, and you see plus 10 dBu at the output, set the meter to 0 by using the front panel adjustment trimmer. So we're gonna get our Phillips back on our mini screwdriver. You see I've got like a bigger screwdriver and a smaller screwdriver. Well, mini ones for doing this kind of stuff. There we go. So I'm turning this little tiny adjustment knob at the bottom so I get 0 on my screen here. Now when the attack control is on, and you see 0 dB at the output, which I do, 0.778, mazel tov. want me. It's a fuck you. Maybe it ran out of batteries. I hope not. Excuse my language, people. Mode AC. Hello. All right, so 0.778. All right, we're still cool. So now that I've turned the attack all the way fully clockwise, I see 0 dB at the output, which is 0.775. Use a tracking adjustment, R44, this guy right here, to set the meter to -10. Right now, my meter reads negative like 2, so quite the adjustment's gonna happen. So I'm gonna turn this sucker quite a bit, looking at my meter, until I see -10, which I do. Now the meter actually will show -10 for a physical -10 drop. So if I go back to 0, goes back to 0, I initiate a 10 dB drop, I read 10 dB on my meter. I'm a little bit heavy actually. I'm gonna come back a skosh. There we go. Beautiful. My meter totally settled. My meter actually is still a little hot. I don't need this in anymore. It's not changing. There we go. Meter's at 0 now. All right, that's pretty darn close. Remember, this is a subjective science. We want to get this right as we can, but we have a little more leeway in this side of things. So we're really close on all fronts. Everything looks good. It's reading the appropriate stuff at the appropriate voltage. We'll turn down the input, turn down the output, kill the ratio. Like I'm showing 0 on my meter, it's great. Turn it off.